My name is Emmanuel Odigwe, and the topic of my presentation is remediation of soil contaminated with organic compounds by nanoscale zero valent ions. Organic contaminants can be defined as chemicals that are carbon-based, for example, organic solvents, petroleum-based wastage, pesticides, domestic wastes, disposal of sludge over land, personal care products disposal, liquid phase volatile compounds, electronic wastes, and so on. Impacts of organic pollutants. Exposure to high levels of air pollution can cause a variety of adverse health effects. It increases the risk of respiratory infections, heart diseases, and lung cancer. Both short and long-term exposure to air pollutants have been associated with health impacts. More severe impacts affect people who are already ill. Also, exposure to water pollution can lead to diseases such as gastrointestinal problems. We have bacteria, parasites, and also chemical waste, which, when introduced to the water or water bodies, can lead to so many adverse health effects. Then, pesticides, which is a pollutant in the soil, can lead to nausea. You also have the risk of having cancer, skin irritation, and so on. Also, carbon monoxide, which is a waste product of most industries or factories, especially in a country like Nigeria, leads to the depletion of the ozone layer, which in turn causes cancer. Then we also have lead poisoning, which can lead to so many diseases, causing adverse health problems for men. Conventional remediation approaches include pump and treats, thermal treatments, suffocants, cool solvent flushing, chemical oxidation, chemical reduction, bioremediation. Nanoparticles have important uses in cleaning groundwater and soil for the environmental sector. Nanoscale zero valent ion is particularly diverse. By injecting it to the affected area, it can dechlorinate organic solvents, detoxify pesticides, immobilize metals, and transform fertilizers such as nitrates. Other nanoparticles can also be applied to these issues, such as bimetallic nanoparticles for dechlorinating organic solvents and carbon nanotubes for detoxifying pesticides. It also has so many benefits, such as low cost and toxicity, strong reducing ability, large specific surface area, high reactivity, and the benefit of having different processing approaches. Synthesis of nanoscale zero valent ion. We have the physical methods, chemical methods, and microbial method. The physical method involves the application of mechanical means and high energy to break down bulk ion materials to nanoparticles. The chemical method involves the aqueous phase reduction using iron and sodium borohydride, while the microbial method involves green synthesis of nanoscale zero valent ion using plant extracts and microorganisms to reduce iron. Factors influencing soil remediation. Physical and chemical properties of soils, such as pH, temperature, and organic matter, affect soil remediation. Another factor influencing soil remediation includes natural organic matter, ionic strength and dissolved oxygen, increasing temperature, and also the pH levels. Nano zero valent ion is emerging as a new option for the treatment of contaminated soil and groundwater, but was first applied in 1997 for the complete removal of TNT. NZVI, along with electrokinetics, is a promising remediation technology. Ultraviolet light and ultrasound assist NZVI under aerobic condition. Modified NZVI or nanoscale valent ion has better application than unmodified ones. Challenges and risks associated with nanoscaled zero-valent ion particles. The use of nanoscaled zero-valent ion particles to remediate contaminated soil has received increasing amounts of attention within the last decade, primarily due to its potential for broader application, higher reactivity, and cost effectiveness compared to covalent zero-valent ion applications and other in situ methods. However, the potential environmental risks of NZVI in situ field scale applications are largely unknown at the present, and traditional environmental risk assessment approaches are not yet able to be completed. Therefore, it may not yet be fully clear how to consider the environmental benefits and risks of NZVI for in situ applications. Another challenge is the high cost of transition metals. Lack of understanding of the underlying behavior of NZVI particles. Reactivity of organic matters and inorganic minerals affecting NZVI need to be explored. Long-term impacts of NZVI on soil ecosystems is not clear. Soil remediation using NZVI is a promising technology, but needs more scientific investigation to address the concerns. Below are my references. Thank you for listening to my presentation.